Hey math fans, we're on section 2.2.1. Let's get started. A quadratic function can be written in the form of f of x equals ax squared plus bx plus c, which is also known as the standard form of a quadratic function. Remember that in the standard form, we have a couple of different things that appear right away. We know that c is going to be the constant term, which is going to turn into the y-intercept, only in the standard form. And then negative b over 2a will get us the vertex. We also have vertex form, which remember that k is not the y-intercept. It is actually the y value for the vertex. So you have h and k is your vertex in this particular parabola. And finally, factored form. Factored form is great to find the x-intercepts, also known as the solutions to the quadratic, in which case it will be p and q. Remember that in both of these, there are negatives in front, and so you have to be careful. The x-intercepts of a quadratic are where the parabola intersects the x-axis, or in other words, when y is equal to 0. Here we have x-intercepts of negative 2, 0 and 2, 0. The x-intercepts have several different names like roots or zeros or solutions. Here's a table of values where we can kind of pinpoint some of the x and y intercepts. Remember, if you want to find a y-intercept, the x will be equal to 0. And if you want an x-intercept, the y will be equal to 0. A question might ask you, where is the function increasing? So as you go from left to right, you can see whether or not the function is increasing or decreasing. In a parabola, there's always the point of turnaround, which is called the vertex. When we are asked whether or not the function is increasing or decreasing, we are going to specify the domain where the function is increasing or decreasing. The function on the left here says that when x is less than 0, it is decreasing. And clearly, when x is less than 0, we're on the left side of the graph is where x is less than 0, it is decreasing. And on the right side, it is increasing. And the opposite is happening in the other graph. It starts to increase first, then decrease and decreasing. And finally, end behavior. End behavior is a statement that we're going to be talking about what's happening in the long run to f of x. Is f of x approaching infinity? Is it approaching negative infinity? Is it approaching some number? In which case you have an asymptote. And so we'll be discussing all of the end behavior statements in this section as well. Rather than work with a parabola, I decided to work with a polynomial, x to the third minus 2x. It kind of looks like a roller coaster of a function. There are a couple different places on this particular function that are increasing or decreasing, and there's several different domains, and I want to go through each one of these questions. The question says, what are the x values for which the function is increasing or decreasing? What's the maximum, the minimum of the function? What are the x-intercepts? Is the function even, odd, or neither? These are all known as key features. First question, where is the function increasing and decreasing? We're going to specify where in the domain is the function increasing or decreasing. So we're going to be talking about the x values here. As we go from left to right on the graph, I can see that the function is increasing. Notice how all the y values are getting larger. Up until a point, though. So you have the y values getting bigger up until right about there, right at negative 0.816. So what we're going to say over here is we're going to say this function is increasing from negative infinity, meaning all the way to the left, and as x approaches this number of negative 0.816, the function's increasing. But at negative 0.816, it's going to turn around. Then it starts to decrease. So notice I've specified over here that it is now decreasing from negative 0.816 all the way to positive 0.816. So it's going to stop decreasing right here. And it's going to turn around once more. Then it starts to increase again. And since it never decreases ever again, we're going to say that it's going to be increasing from 0.816 all the way to positive infinity. Notice how for each one of these, I'm talking about the x. Where in the domain is the function increasing or decreasing? Are there any maximum or minimum values? Maximum and minimum values are obviously the high and the low points on the graph. Where's the highest point on this graph? Where is the lowest point on this graph? Well, it's kind of tricky because there is a high point, but it's not the highest point. So we will call it a relative maximum and a relative minimum because there are lower and higher points to both of these points. The highest absolute point we'll call an absolute maximum or an absolute minimum. There are no absolute minimum or maximum values. This function will continue on to positive infinity. There is no high point, and it will continue on until negative infinity. There's no low point. In a parabola, you definitely have an absolute minimum and maximum, but not in this particular function. What are the x-intercepts here? Well, it's wherever the y value is equal to 0. So there are 3 x-intercepts. Also, the point 0, 0 is the y-intercept as well, because that's where x is equal to 0. So 0, 0 is kind of doing double duty. It is an x-intercept and it is a y-intercept. Is the function even, odd, or neither? Well, the way to determine that is to substitute either negative 1 or negative x, and we're going to look for sign changes. Both signs have changed in both terms, which makes it an odd function. Finally, describe the end behavior. What's happening to this function as x approaches negative infinity? What's happening to this function as x approaches positive infinity? So we're going to write 2 statements, and we're going to be using arrows. So this is how we read this. We say as x approaches negative infinity, f of x, which is y, approaches negative infinity. And isn't that what's happening in this direction? As x is getting really small or approaching negative infinity, isn't y also approaching negative infinity? And then the second statement says as x approaches positive infinity, in other words, as it's traveling to the right, isn't y also approaching positive infinity? Here are some more end behavior statements for even and odd powers. Again, we read this as the arrow. We read the arrow as approaches. As x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x approaches positive infinity. Quadratics are pretty simple when it comes to end behavior statements and domain and range and key features. They always will be increasing and then decreasing or vice versa. They will at most have 2 x-intercepts. And the end behavior is always going to be positive or negative infinity for the y value since it turns around at some point. And that's going to do it for this section. We'll see you in class.